Hi, we're team number 1, and today we will present to you how to manipulate a chemical reaction to increase the productivity of a company. A family business is dedicated to the production of ethyl acetate, and they want to know a way in which they can maximize the production of this product.
What is expected from this problem situation is for us to identify if there's a way to optimize the production of ethyl acetate and to inform if the use of it will favor a sustainable development.
Well, here we can see some of the properties of ethyl acetate and how it is used in nail polish remover, aroma enhancers, perfumes, etc.
One of the questions asks if the amounts of ethanol and acetic acid needed to produce ethyl acetate were the same. This meaning that to produce, for example, 1 ton of ethyl acetate, 1 ton of each reactant will be needed. The previously statement is incorrect as the amounts of ethanol and acetic acid needed to produce ethyl acetate are not going to be equal. Acetic acid will be the limiting reactant.
If the company has 500 liters of ethanol and 500 liters of acetic acid in inventory, what will be the maximum amount of ethyl acetate that could be produced? To solve this, first we have to know which is the limited reactant. After the equation that are shown in the image, we get the amount of moles of each reactant. Because the two reactants have a ratio of 1 equals to 1 product, the one which has less moles is the limited reactant. That amount of moles is of the product. Then we multiply that value by the molar mass of ethyl acetate. After that, we get the maximum amount of ethyl acetate that can be produced, which is 754.49 kilograms.
Could you explain if the production of ethyl acetate can be increased by removing the water? Yes, if we remove the water from the equation, it will create an effect on the equilibrium. And according to Le Chatelier principle, in this case, by removing the water, the reaction will shift to the right. This disturbance in the equilibrium of the reaction is going to cause the production of more ethyl acetate.
The following question asks if there is a way to favor the production of ethyl acetate, like for example, changing the temperature or the volume. And the temperature, yes, it does help since the reaction is exothermic. If we take away the heat, then it would favor the products. But in the volume, it doesn't because both of the sides have the same amount of moles. So it doesn't favor any side.
Effectively eliminating the water can increase the production of ethyl acetate. And now, how can the water be eliminated? To eliminate the water, we could add a drying agent. This is a chemical used to remove water from an organic compound that is in a solution. Some examples of commonly used ones are calcium chloride or sodium sulfate. Another method we could use is fractional distillation.
How can you estimate how fast ethyl acetate is produced? A way to estimate how fast ethyl acetate is produced is by letting ethanol and acetic acid react, and when the reaction is finished, analyze the amount of time it needed to produce the given amount of product. Then divide the amount of product by the time, which will give you how much amount of product you will get by a time value. An example is the following. After 1 hour, the reaction is done and you get 1000 moles of ethyl acetate. Divide the 1000 moles by the 3600 seconds, and you will get that the rate is 0.278 moles per second. With this value, you can determine how fast the product is produced.
Is there any way that the ethyl acetate production process can be speeded up? Yes, we can use a catalyst. A catalyst is a substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. In this case, a way of increasing the production of a process is adding a catalyst to increase the rate of it.
What are green processes? These are chemical products and processes that reduce or eliminate the use of generation of hazardous or toxic substances.
Properties of ethyl acetate that can help promote its use in green processes. It's considered to be one of the chemicals that has the least negative environmental impact. It is used to replace more toxic solvents such as chlorinated solvents, petroleum ether, and hexane. Due to its low environmental impact, it is also properly detoned as green solvent.
What I've learned from this course is the importance that chemical reactions have in our everyday life. because sometimes we are not even aware of their presence, but they're still there. And it's good to know there are some ways to optimize it to get better results, or just to have them be more eco-friendly.
What I think the most important thing I learned in this course is basically the equilibrium of the reactions and how we can manipulate them to obtain what we want, in this case being ethyl acetate. I think everything we learned about that, rising up the heat or taking it away, adding more reactants, adding more products, I think that is what really helped us during this project.
My name is Hector Cantu, and this is my reflection. So, chemistry is vital for the way in which our societies live. With its knowledge, we can have our technology, infrastructure, and even our large food production. With the things that we learn in this partial, we can make a reaction faster and more efficiently, which is really valuable knowledge because we can apply that in a business to improve its product.
Chemistry is very important in our daily life because it helps us explain all of the processes that happen around us. Topics such as the chemistry, acids and bases, chemical equilibrium, and rate laws help us understand the processes that matter follow and how they are formed.
What I learned from this course is that everything in chemistry has to be balanced. Every equation and everything always finds a way to be in equilibrium. I loved Le Chatelier's principle and how everything we do to our equation makes a reaction in it.